Hello guys, in this video I'm gonna solve a circuit, but this time using mesh analysis. So in our previous videos, we tried to explore how to solve AC circuits with different methods. We tried Thevenin's, we tried the nodal method, and we tried also the superposition, okay? I choose another example here, another circuit, which was part of your homework, okay? So that I give you an idea about the solution of the homework. At the same time, another method, which is the mesh analysis. One important thing also in that particular question, or problem is that we're gonna also use another useful tool for the first time, which is a tool, online calculators that solves linear equations with complex numbers together. Okay, I didn't explore this before with you, and this is the first time to touch upon this new calculator to save your time and get accurate results. Okay, so how we can apply like the mesh analysis in AC circuits or any circuits actually. Okay, again, it's exactly the same methods that we use with DC circuits with no capacitors and inductors, but this time we're gonna have like AC sources, inductors, and capacitors. So instead of having only pure resistances, basically real parts, with no imaginary, now we're gonna have like complex numbers, okay, because we're gonna have reactances. Okay, so let's explore this problem together. So in this problem, IA T is required, okay? And Vs is given, Vs, which is the source, Vs equal to 40 sine 200 T minus 20 degrees volt. Okay, so Vs is given as in the time domain as a sinusoidal function. And IA of T is required. Okay, so before we start, we agree that for this kind of circuits, we should convert the circuit first to the Phasor domain, okay, it's complex numbers, and then solve it in the Phasor domain. Then we can go back to the time domain if it's required. So like this question, for example, we want like A of T, okay? So we also agree that we use also sine and cosine, both are called sinusoidal functions. We use cosine all the time, okay? But here it's given sine, not cosine. So we should convert the sine into cosine first. So how we can do that? So we know that sine theta equal to cosine theta minus 90. So basically we're gonna subtract the 90 degrees. We're going to subtract 90 from the phase of this sine function, and it will be cosine. So Vs of t can be written as 40 cosine 200 minus 20 degrees minus 9. So it will be equal to 40 cosine 200 minus 110. Okay. Then we convert the circuit into the Phasor domain. Okay. So in the Phasor domain, Vs of t will be like that, will be 40 angle minus 110, easy peasy. Now the capacitor 200 microfarad. This guy has a reactance. This reactance is J, or yeah, minus J over omega C. What is omega here? So omega is equal to 200. Okay, 200. So minus J and omega is 200 multiplied by C, which is another 200 microfarad. Okay, so that will be, if we calculate that, that will be J25. It will be 10,000 divided by 4, divided by basically 4,000, which is basically 25. Okay. Now we convert the inductor. So the inductor is 50 millihenry. So that will be J omega L. J omega is 200. L is 50 million. So that by the end of the day will be J10. And calculate it and verify the answers. Okay. So this circuit can be shown like that. You can replace the capacitor with any like box shape. It's just a reactance, okay, or impedance, and this impedance is J25. Resistance still the same. Resistance still the same, 10 ohm. Then the inductor will be J10. And for the source, it will be 40 angle minus 110. That's the circuit in phasor domain. And we're gonna find I capital A, which again in phasor domain, then we convert it back to time domain. Okay. We're gonna solve this using the mesh analysis. So we must assume the currents in each branch in this circuit. Okay. So let's assume the current here is called I1 and the current here is called I or I2, whatever you like. Okay. Okay. So first let's calculate I. So I at that node here, let's put node X at node X. The amount of current going into the node equal to the amount of current going out of the node. Basically KCL. So we're gonna apply KCL, Kirchhoff current law, at X. That leads to I1, which is entering the node, equal to IA plus I. IA is going out, I is going out, so I1, which is going in, equal to IA plus I. From that, we can say that I equal to I1 minus I. Okay? So I'm going to write directly on the circuit I as IY minus 1, minus I. So minus IA. I1 minus I. Okay, just to reduce the amount of unknowns that we have. Now let's apply with the mesh analysis. So applying the mesh analysis. So what we do in mesh analysis? Basically, we apply Kirchhoff voltage law in each loop we have in the circuit. Then we solve. We're going to have some linear equations in some unknowns. And of course, the number of unknowns should be equal to the number of equations that we have. Then you solve these equations together and you get the unknowns. Okay, so we have here two meshes. We have here mesh 1 and mesh 2. Kirchhoff voltage law needs the directions of, or the voltages, and the direction of the voltages. So let's do what the directions in another color. So let's have, for example, red here. So always the voltage is opposite to the direction of the voltage is opposite to the direction of the current in any element except the battery, the source. Okay. So for example, here is the battery of the source, the current is going up, which is I1, and also Vs. Which is known 40 angle minus 10. Then we have the voltage, the J25, it will be that way because I1 is going this way, so the voltage will be the opposite, that way. For mesh 1 also we have the 30 ohm, right? And the current is I1 minus IA going down, so the voltage will be going down like that. And the voltage is the current multiplied by the reactance or the resistance or the impedance. Okay. Let's do mesh 1 first. Okay, so mesh 1. So we gotta start from any element and we just loop across the loop. Okay, so BS is going up. So let's assume the direction of base is the positive direction. You can assume it's the negative direction. That's fine. So when we look like that, we're gonna find that J25 voltage is opposite. So this will be minus the current, which is I1, multiplied by J25. The current of the impedance or the resistance is the current flowing into the resistance multiplied by the resistance or the. We continue looping like that, we're gonna find that again the voltage across the 30 ohm resistance is opposite to the positive direction that we minus, and the current of the 30 ohms is I1 minus IA. I1 minus IA multiplied by 30 equal to 0 because there is no other elements in that loop. Okay. We can bring I1 J25 and I1 minus A30 to the right hand side. It will be positive. So VS, which is 40 angle minus 110 equal to I1 5 plus I1 minus IA multiplied by 30. Okay. I'm going to convert the 40 minus 110 into like a rectangular form. For some reason, I'm going to explain, in a bit, like in 1 minute maybe. Okay. So let's convert it. So again, we use our this calculator here. So we enter enter the radius, which is 40. The angle is minus 110. And we calculate this. That will be minus 1368 minus 37.59 J. Okay. We don't need the calculator more. Now equal I1 25 plus I1 30 minus IA 30. Okay. So minus 1368 minus 37.59 J equal to I1 25 minus plus 30 would be basically 55. Minus third IA multiplied by 30. Okay. That's mesh number 1. Now let's do mesh number 2, loop number 2. Let's have another color as well, like for example, green. Okay. So mesh 2, which is this one here, number 2, on the right, we have 3 elements. We have the 10 ohm, we have J10, and the 30. Okay. So the voltage IA is flowing in that direction, so the voltage will be opposite. For the J10, the voltage is going, the current is going down, so the voltage will be up. And again, for the 30, still the voltage is going up because the current I1 minus A is going down. So in mesh 2, let's assume the J10 is a positive voltage. So we have IA multiplied by J10. This is the voltage across the J10 plus IA multiplied by 10. This is the voltage across the 10. Okay. Minus I1, I'm sorry, minus IA multiplied by 30 equal to 0 because there is no other elements. Okay. So IA J10 plus IA 10 minus I1 30 plus IA 30 equal to 0. So I'm gonna write it in that way. So the constant part will be here equal to I1 first, so minus I1 30 plus IA, and we have like a bunch of constants 40, 30 plus 6, 40 plus J10. Okay, so let's go back now to our original cover. So that's equation number 1, two unknowns, I1 and IA. That's equation number 2, again in I1 and IA. So we have two equations in two unknowns. And one of these unknowns, by the way, is IA, that is the one that we really want to calculate. Okay, so by solving these two equations together, we're gonna find I1 and also IA, which is our main objective. So this is basically a linear system of equations, okay? So we need to solve these two equations together, and this is easy, especially if you have like two equations and two unknowns. But remember, the objective of this, one of the objectives of this like problem is to explore like how to calculate that in a very easy way, very fast way, very accurate way. So we're gonna use an online calculator as well to do that for us. Okay, because the hand calculations, of course, it's good, but it's error prone and time consuming as well. Okay, and the objective is to solve the circuit, not to do calculations. Okay, so let's now explore our online calculator that I'm going to leave its link in the description. So here it is. Actually, I solved this problem before, so I'm going to find the solution there. But we're going to just explore it. That's fine. Okay. It is basically the online calculator, the system, the complex number linear system equation solver. Okay. So in this case, we have like two unknowns and two equations and two unknowns. So we write here two. And here is basically the number of decimal places you want in the output. So for the output here, we write 5. So it gives you the 5, like the complex number with a precision of 5 decimal places, which is good. You can, of course, make it 2 or 3, whatever you like. Let's make it 3, for example, in our case here. Because we agree, like last videos, that 3 is good, or even 2. That's fine as well. Okay. So each coefficient here, in the equation, you put it in that way. Remember, it's a complex number. Okay. So complex number has real part and imaginary part. You will not write J or I here, to represent the imaginary part. But instead, the order is important. So always in this parenthesis here, the first element is the real part. Second element is the imaginary part. Okay. So let's explore our equations and see how to write that. So the first equation is I155 minus IA30. Okay. Oh, this is I, by the way, this is J. So here there is J here. Like type. Okay, J again, another J. And of course, okay, that will not be 55 anymore because we cannot add J 25 to 30. We just write them together. Okay. So that case here, this will be 30 plus J25. I am very sorry. Okay. Now, let's write or put this coefficient here in that. So, so here we put like the coefficient of the first unknown, which is I1. 30 plus J25. So we write 30 here, the first like slot of the parentheses. Then we write J25 in the second slot. Okay, again, we might have a problem because this is basically here negative. Here it's positive. Oh, I'm sorry. So again, another mistake. So that's basically here minus J25, not positive. So let's write it with the original right color. So that's minus J25. Okay, minus J25. So we have here minus. Now with the red, this will be minus J25. So overall will be minus because minus and minus here is positive. When it goes to the right hand side, it will be minus again. So again, minus here, and that will be minus 30 minus J20. Okay. And again, these like kind of problems really very error prone. So you must be like very careful when you do your calculation. Okay, I'm gonna write it clearly again here. So I1, J25, I1, J25. Okay. The second coefficient is minus 30, minus here and 30. And there is no imaginary. So we put 0 equal to, so this is the first equation. So it has like a constant part, which is that one. That's why I convert the 40 angle minus 110 into a rectangular form. Why? Because in that website here needs the rectangular form. So the real part is minus 13.68. The imaginary part is minus 37.59. That's the first equation. Now the second equation. Second equation is easier. The constant part is 0, 0. Now the I1 coefficient is minus 30 and there is no imaginary. And I2, or I'm sorry, IA coefficient is 40 plus G10. So 40 is the real and 10 is the like imaginary. And then we make up the coefficient, solve the system, and it gives you the answer here. So let's put the answer. Actually, I can copy and paste, but let's write the thing down. That's fine. So the answer, IA or I1, of course, we write here I1 first. Okay. So the first like solution is actually I1 is 1.33 minus J 129.122. And it gives you the answer is rectangular and also polar. So that equal to 1.85 angle minus 44.119 degrees. Now IA is second unknown. Now it's known because we solved it. It is 0.711 minus J 1.145. This is in rectangular. Now the polar form is 1348 angle minus 58.155 degrees again. This was part of the homework, so I know that now you might be like looking at your solution and yeah, it's correct. And it is correct. Okay. So that's IA, but in Phasor form. Let's now go back to our like normal screen. So that's IA, but in Phasor form. Now let's bring it back to the like the time domain. Okay, so in time domain it will be IA of t. We'll write it in small letters. Okay, that will be like the amplitude of the cosine. Remember, it's a cosine, not sine. 1348 cosine. Omega is the same. We have it from before, 200t. And the phase is 58 minus 58.55 degrees. Okay, that's basically the IA in time domain, and that was actually the requirement or the task in that problem. Okay, guys, that's basically how to solve using mesh analysis. We also learned how to solve linear equations with complex numbers, in a very easy way using our online linear equation with complex numbers solver, which I will put the link of this website in the description of that video. Okay, thank you very much for watching and see you in another video. Bye bye.